Hi everyone. This is my AP Chem project, and today I'm gonna talk about acid-base titration. And before going on, I'm gonna assume everyone here is familiar with the concept of titration, or at least like done one of these setup over here, like but but I'm gonna introduce anyway. Titration is basically a technique used to determine the molar concentration of an acid-base solution using another titrant, and a titrant is usually um, you know put into this bird over here, which is clamped onto a stand, and this is a flask containing the solution that we want to be titrated. So this should be titrant and solution that we wanted to determine the molar concentration. Alright, so this is pH meter, which monitors the progress of the reaction by measuring the pH at each added volume of the titrant. Alright, so this is the titration curve. There's pH. It's basically like a graph of pH versus the volume of titrant added, and equivalence point is basically the number of moles of the solute in the original solution equals the number of moles of titrant. Now we can basically use our eyes to see this. We can only tell when we add certain indicators, right? Like phenolphthalein or litmus or whatever acid-base indicator. It would change color in the proximity between in proximity of the equivalence point. So we must, for each titration, we must choose one that is suitable. So basically, that's what it is about titration. But today I'm going to focus more on the types of problems dealing with acid-base titration. So basically, there are two types of problems. We have strong acid, strong base, strong acid, strong base, and we have weak acid, or with weak acid, strong base, or we can say weak base, strong acid if it's the solution, if it's a basic solution that we want to be titrated with. But for the sake of making it easier for me to instruct you guys, I'm gonna assume the solution to be titrated is acidic. Alright, so that's my assumption. Alright, so here's how it works. I'm gonna write a sample question, and then I'm gonna show you guys how I'm gonna do it. And after that, at the end of the video, I think I'm gonna sum up the general strategies in attacking these kinds of problems. And okay, so for the first type of problems, which is the strong acid, strong base question, they're gonna give you basically the volume of the solution you want to be titrated to it, but and they also give you the molar concentration. What they'll be asking you is the pH of solution at each volume of titrant added. So let's just say we have 15 milliliters of 0.1 molar of HCl, which is a strong acid, and we want it to be titrated with 0.1 molar of NaOH. Now, There are possibly 4 scenarios of the number of the volume, and each will have sort of like techniques or kind of what you should do in dealing with each kind of problem. So we can say before titration, that is to say before any of the base is added. So it would be 0 milliliters added. And the second scenario should be like some base is added, but it's not enough to go to equivalence point. So this is before equivalent point. And now the third scenario is when at equivalence point, what happens? So at equivalence point, or in this case 50 milliliters of NaOH is added. And finally, we have a scenario where there's excess of base. For example, we have 60 milliliters, and it's obviously in excess. Alright, so I'm gonna be dealing with all of these things and how I'm gonna show you how I'm gonna do it. Alright, so let's just keep it there. Alright, before you add any kind of base into the solution that we want it to be titrated, what's the pH of solution? Well, it's actually just meaning the pH of the acid itself, and basically you guys already know this, right? Like acids, determining the pH of the acids, and weak acids and whatnot, and so it's pretty easy, but I'm gonna show you guys anyhow. Oh, so yeah, because this is a strong acid, so it makes the job easier, and because it's they already give you the molar concentration, so you don't have to calculate anymore, but you can just, if they don't give you one, you can just always remember number of moles of solute over volume of solution is molar concentration. Alright, so because it's 0.1 molar, so it should be 0.1. The concentration of hydrogen ions should be 0.1 also, because this is a strong acid, and this dissociates completely into hydrogen ion. So because it's 0.1 molar, we have the pH equals negative logarithm of concentration of hydrogen, and this is a really important equation to remember for any type of problem dealing with titration or acids and bases and whatnot. Right, so and we can crank this out in our calculator. Right, so it's pretty easy, pretty straightforward for the first type problem. Now the next type of problem is when some of this is added, but it's not enough to go into equivalence point. So what happens? Well, what we should do in this case, we have 40 milliliters of this added, so we should probably calculate the number of moles of each type. So numbers mole of this in the whole solution, like we should say 0.1 molar times 0.05. Make sure that it's in correct unit. So it's like 0.005 moles. Oops. And 0.1 molar times 0.04 liter, which is to say 0.004 molar. Now we obviously know that this, because the ratio is 1:1, so it's easier for us to compare. But in some cases, they may give you hydrogen sulfate, which case you have to write out the equation for it. But this is for a simple illustration of how titration problems usually work. So because this isn't, there's still some left after these neutralize some of this, we still have number of remaining HCl, which is 0.005, negative 0.001. This is 0.0004, sorry, one mole. Now we have to find the new volume in order to calculate the concentration of the remaining acid. So the new volume should be 0.05 plus 0.04, which is 0.09 liter, and we use these two information to find the concentration of this, and we can find concentration of hydrogen ions because it's a strong acid, and then just find pH, which we already know what to do. And next up, equivalence point. Now this is pretty easy since this is a strong acid, strong base, and they're all in equal ratio. They're gonna dissociate completely into a neutral salt and water. In this case, it's NaCl and H2O. Since this is neutral, pH is always 7, like always, at equivalence point. Now next up, we have what happens when there's an excess of base. Well, it's pretty easy. You just it's pretty similar to the second phase where there's still remaining acid, but the only thing, one more step you need to do is after you find the concentration of excess NaOH in the new volume, you have you can only conclude the concentration OH minus. In this case, you find the POH instead of OH, and to find the pH, you need to subtract that from 14, and we all know it comes from this type equation, POH equal 14. So that's another important equation you need to know for any kind of acid-base titration. Alright, so now it's pretty straightforward. Now we're gonna deal with the second type of acid-base titration, which is a weak acid and strong base. Now you can do this with weak base and strong acid, but again, for the sake of making my sort of instruction video easier for me, I'm gonna assume the solution to be titrated is acidic. So let's just say we have 15 milliliters of 0.1 molar of acetic acid, and we want it to be titrated with 0.1 molar, again, sodium hydroxide. And what happens at 4 different phases, I'm just gonna write this down, like before titration, and what happens if there's 40 milliliters, which is to say before equivalence point. What happens at equivalence point, or in what happens if there's an excess of base. Now this is sort of the same thing, but because it's a weak acid, in this case acetic acid, so we're gonna do something kind of different. And we all know, I'm assuming that you all knows how to calculate the pH of a weak acid, which is using Ka. We want to look up the Ka value for the weak acid that we use.